Okay, so let's practice those strategies that I mentioned in the previous lecture with sample questions. If you haven't watched the previous video, then you have to watch that video first before studying this sample question problem set. I'm going to use the sample question from the AP Physics 1 course and exam description booklet, and you can download the file below from the link below this video. And also you can find out the sample, the question that we'll use from the page 216. And the question number one is about quantitative qualitative transition problem. Yes, we'll start from the both strategy 1 and 2 at the same time. Once you actually open the question, you need to read the whole question at first, okay, as I mentioned in the last lecture, okay. And when you read this question, read thoroughly but quickly, okay. We don't have enough time, so we have to read the whole question quickly, as quick as you can, and usually at most in 22 minutes. And while you're actually reading, what you need to figure out is try to figure out what kind of topic is related for that question, and try to estimate how much time you have to spend for each sub-question, and try to write down your own the important information or the core words, okay. So it's not the paper-based question, the exam later, so it's not, you better just write down your memo instead of just highlighting on the question, because you're not able to make a highlight on the screen, okay. We don't know, maybe the question website have this kind of feature to highlight something or take the memo comment. I doubt it, but yeah, anyway, we better just make your own note. So yeah, so you have to read your question first. If you haven't read the question thoroughly, just make a pause this video now and just read and come back after reading with following the strategy 1 and 2. I will assume everyone already did, and let's just think about it. Yes, like you already read, the question is consists with a quantitative and qualitative part and some short answer. A, 1, 2, these are the question about the qualitative analysis, and B1, that question is for the quantitative analysis part, and B2 is actually connecting those two things together. And C, D, E are following short answer question. This is quite interesting part because even in this booklet, the booklet actually giving the introducing this exam as a sample of the qualitative quantitative problem, but also have a short answer questions inside. What it tells us is, although the College Board said we'll have a quantitative qualitative problem and the paragraph argument problem only for this year, I'm pretty sure we'll have these kind of short answer question as a part of those two questions, okay? So usually from the 2015, AP Physics 1 and 2 has not only these two format, but also have the experimental design, but we don't have enough time to have a question asking the design, the experimental procedure, but pretty much you will have question asked about how to analyzing the data and how can you deal with the source of error. These kind of short answer question could be there, okay? So do not ignore them. You have to practice these kind of short answer question as well. Yeah, this is the main part, main statement for the question. And after reading this question thoroughly, what part did you find out as important information or core word? I believe you have to catch at least these two parts. In a horizontal circle with constant speed. So when you read these questions, when you find out this, oh, it's a horizontal circle and a constant speed, oh, this question is about circular motion, uniform circular motion. Okay, so you can actually bring all the information about the circular motion to prepare these questions. And this is question A. What part did you find out? I would catch one aspect and incorrect. Sounds like it's not an important word, but one aspect, when you read, oh, you have to find out what is one aspect of the student one's reasoning that is incorrect. That means you may have more than one statement about incorrect, or you may have some correct part and incorrect part as well inside student one's statement. And among those things, you have to find out one aspect of incorrect part only. You don't need to write down the more than one, even though it has, the statement may have several incorrect part. Or if you have incorrect and correct part, you have to distinguish which part is actually incorrect. These kind of things that you have to catch when you read the first time, and you should be careful when you write down the answer. How about B? What did you find out? Here, I think the magnitude of the net force in terms of m theta and the physical constant, this is the important part for B1. And for B2, one aspect or step, same as the before, and either part A1 or part 2. I think these are the important part. Why? Here, we need to drive an equation. Then we should know what kind of equation we have to drive. Okay, so we need to drive equation for magnitude of net force. We don't need to worry about the direction. We only care about the magnitude only. And this part is very important in terms of m, mass, theta, angle, and physical constant. You should answer with those given variable only. Do not use any other variable except these things. Okay, if you actually find out the answer, the expression of the magnitude of net force with other variables, not these things, although that is true, you're not going to get the mark on it. Okay, so be careful. Whenever you write down the expression, most of case, the question gives the restrictions for the variables that you can use, and you have to use those variables only. Okay, and second thing, describe. This is the connection part. Describe one aspect or the step in your derivation of the part B1 that can be correctly linked to your answer to either part A1 or part A2. So you just described one aspect or step among the several steps or among the various aspects. And you can answer either part A1 or part A2. So when you read this one, what you have to remind is, oh, I have to indicate it. I have to, when you answer it, you should explicitly indicate whether your answer is about part 1 or part A2. Okay? So always, when you have the several cases that you can choose, then you have to explicitly show which one you have to choose. Okay? Okay, so we already know that this question is about the uniform circular motion. In this video, I'm not going to explain every basic concept about this physics, and I assume all the students already know about this kind of the concept already. But to explain this question, I will just explain the core part of the centripetal force. Okay, whenever the object is rotating around the circular motion, we always have velocity to the tangential direction, and we always have, no exception, we always have centripetal acceleration and centripetal force toward the center. In this case, if object mass is m and the radius from the center to the object is r, then centripetal force is mv square over r, and centripetal acceleration just simply v square over r. And we can express this one in terms of a period as well instead of the velocity. If you know the period, okay? Oh, so instead, so how can we drive it? So velocity, what is the velocity? Velocity is distance over time. The basic definition never changes. Velocity is that distance over time. When we have a circular motion, distance over time. What is the distance for the full circular motion for one circular loop? Circumference. 2 pi r. And what is the time to finishing this one complete loop? That is a period. That's the definition of period. So you can actually substitute this v with 2 pi r over t, then you can get 4 pi square mr over t square instead of mv square over r. And if you bring down this m, then this centripetal acceleration is also 4 pi square r over t square. So depending on whether the question gives the velocity or the period, you can choose one of them to choose it to solve the question. Solving is not a big deal. The most important thing for here is on this side, I use F equal ma. If you multiply the mass on the centripetal acceleration, that becomes centripetal force. What it means, centripetal force is not an individual force, like a gravitational force or friction force, tension. No, this centripetal force is the F equal ma. This is always true, F equal ma. On this simple F equal ma equation, what is F? That F must be net force of the system. It's net force, it's not the one individual force. So centripetal force is always net force of the system having circular motion with constant speed. Okay, so that's the key thing about the centripetal force. So centripetal force is net force. So if you have several forces, when you actually get the vector sum of those forces, those applied force on the object, the sum must be toward the center from the object, and that becomes centripetal force of the object. So on the free body diagram, we never draw the net force on the free body diagram. On the free body diagram, we actually draw all the forces applied on the object. And the main reason why we need to draw the free body diagram for any kind of the dynamic problems, to find out net force by using vector sum of the actual individual applied force on the object. Once you actually get the vector sum of it, that vector sum is equal to net force and centripetal force. Okay, that's the key thing. And this is the part that student 1 made mistake. Now, do you remember what was the strategy number 3? Strategy number 1 and 2 is to read the whole question thoroughly at first and collect all the information and the important information in the core word while you're actually reading. And the strategy number 3 is do quantitative analysis part first. Okay? Once you actually get the mathematical expression for the core concept of the question, it's easy to make some kind of statement for qualitative analysis. So better having the mathematical expression first. So let's start our B1, because for this question, B1 is the quantitative analysis part. Okay, the B1 asking find the mathematical expression for the net force, magnitude of the net force of this system. So what we have to do to find out the net force, first step is always starting from the free body diagram. We have mg downward, tension along the string. This is the net force, nothing else. Like student 1 said, there is no force toward the center from the sphere. There's no individual force of that. Okay? So if the question actually asks what is the correct part, then the correct part for the student 1, then might be you can just say, oh, the student 1 says there's no individual force toward the point C from the object itself. That might be the correct part. Okay? Here, when you have a free body diagram, if you have any force is not aligned either horizontal or vertical, then we need to breaking into the vertical component and horizontal component. So tension must be breaking into horizontal component, the vertical component. Instead of this tension, we'll use tension cosine theta, because this angle is a theta 0. Tension cosine 0, theta 0 to upward, and tension sine theta 0 toward the center. Okay, it has a horizontal circular motion only, so the vertical net force must be 0, because upward force, downward force must be balanced to each other. So tension cosine theta 0 is equal to mg, and horizontal direction tension sine theta 0 is only forced toward the center, so that is equal to centripetal force, okay, which is the net force. Okay, I'm going to use net force. Of course, that is a centripetal force, but this question asks about the net force. I'm going to write down the net force here. Yes, a lot of students actually write down tension sine theta 0. Or some students think, oh, net force, I know the net force is centripetal force for this case, so net force is mv squared over r. Aha, I got the answer. No, none of them is the right answer. Why? Because the question says you need to express that equation in terms of m theta, for this case theta 0, and physical constant, for this case g. You need to use these three, not tension, not this v, what, vr, whatever. Okay, so from here, to use these variables, we need to substitute this tension out. So from here, tension will be equal to mg over cosine theta. So plug in here, you will have mg over cosine theta 0 times sine theta 0 equal our net force. And what is the sine over cosine? That is the tangent theta. So our final answer will be mg tangent theta 0 is equal to our net force. This is the magnitude of net force, which is answer for B1. From previous slide, we actually find out the mathematical expression for the net force. If I just write down one more time over here, our net force was mg sine theta, mg tangent theta 0, and that one is actually aiming this direction. Okay. So, and also we found vertical component of tension cosine theta balanced with mg downward. Okay, these things are the things that we found out from the B1 mathematical expression. Once you have these things, it's very easy to find out the answer for A1 and 2, because it's very easy to understand what kind of mistake student 1 and 2 made based on this calculation. Okay? So student 1, what is the big mistake of student 1? Student 1 thought centripetal force is one of the physical force. So it's one of the individual force. So she thought, or he thought, there must be centripetal force toward that. So maybe if we ask us draw the free body diagram to the student 1, student 2 may draw the horizontal force this way and label the centripetal force. Okay, that is the mistake. Okay, centripetal force is net force, so we cannot have that one, and it's fine although we don't have any individual force this way, as long as we have a net force to this direction. Then we found that one from the mathematical expression. So now we need to explain that one. And student 2, what kind of mistake the student make? Is the student 2 believe tension should be always equal to force of gravity. Okay? This is common mistake for the student who are actually studying the physics like grade 11. When they learn the normal force first time, a lot of students believe the normal force is equal to mg all the time, but normal force is variable and normal force could be changed. So those students make a lot of mistake when they actually calculate the friction, because strict friction could be mu normal force, and normal force could be different with mg depending on the situation, but they just plug the mu mg, so they got the wrong answer. Same mistake or similar mistake. Okay, so like those students believe the normal force is always mg, this student believes the tension is always equal to mg. But for this case, tension not necessarily always equal to mg, so tension vertical component is balanced with mg. That's the part of the student 2. So how can we answer for that? So if I just erase this part, okay. So possible answer for A1 is an object can have a centripetal force on it without an individual force pointing toward the center of the circular motion. Because the centripetal force is a net force on the object, not an individual force on it. The horizontal component of the tension from the string provide the centripetal force on the object. Okay, you can answer this one or this part or other way too, but your statement should have the centripetal force is not an individual force, so not having individual force toward the T doesn't make any problem for this case. Okay, you need to explain that one for student 1. How about the student 2? Tension force is not necessarily same as the force of gravity. So for this case, tension is larger than mg and the vertical component of the tension is equal to mg. You can explain these kind of things for answer A2. Now, B2 is a connection problem. It becomes very easy, isn't it? Because we already know, we already make a mathematical expression first, and based on the mathematical expression, we answered the qualitative analysis part. So we already know the connection. Okay? So we can just describe those connections over here. Okay? So a vector sum of the tension and the force of gravity on the object is in the horizontal direction and equal to the horizontal component of the tension, which is the tension sine theta 0. It is correctly linked to my answer to part A1. Okay? So like A1, A2, when you need to answer one of them only, not necessarily both. Okay? And when you answer, you have to explicitly show what part is actually linked with your statement or a part. Since the question says that on an aspect or a step, so you can actually using free body diagram. You can just say, according to my free body diagram, it clearly shows the vertical component of the tension is balanced to mg for this part A2, which is equal to tension cosine theta. So you can use your free body diagram to answer this connection part. Okay? Yes, in this whole video lecture, I'm just focusing on how to deal with this kind of quantitative, qualitative transition problem. So I'm not going to explain about the C, D, E, those short answer questions for the data analysis from the experiment for the oscillation, and the last one is about the rotational problem. Yeah, I'm not going to explain those kind of things, but if you have a question, always don't hesitate to contact me through the email, and I will answer those questions for you guys. Okay, thank you very much, and hope to see you again in the next lecture for paragraph length argument problem. Thank you.